Okay lads, what we're going to have a look at today is resistors in parallel, and like resistors in series there are some rules that you have to remember. So if you make a note of these, rule number one is the formula for the total resistance in the circuit: 1 over RT equals 1 over R1 plus 1 over R2. The second rule is the total current in the circuit is the current going through one resistor plus the current going through the other resistor, I1, I2. And the voltage that is applied to the resistors is the same all around. And that voltage being the same is quite important. If you look on this rig, I've set up these two resistors, R2 and 3, are in parallel, and you can see basically one end is connected to the other end and the other end is connected to the other end of the resistors, like that, and then the supply goes off to the power supply. So when the voltage is applied, it appears to be the same across each resistor. So you can see there, if I measure the voltage across this resistor, I'll pick that right way around, you can see that is nearly 12 volts, 11.9, and this one should be about the same, 11.9, it's exactly the same. And if I had another one in parallel, it would be the same, another one and another one. So it doesn't matter how many you've got in parallel, the theoretical voltage across them is always the same. And that's the same for your customers. They're all connected in parallel to your network, and they should all be receiving the same voltage. So in terms of the current then, if this is our voltage here, when the current gets to this point here, it splits. Some of it goes that way and some of it goes that way. Goes through the two resistors, so we can call that one I resistor 1 and this one I resistor 2. And then when they come out of the resistors here and here, they join up and go back to the source. So the outgoing current is exactly the same as the incoming current. Right, so first of all we need to remember how to first of all, we need to work out a couple of things. First of all, the total resistance in a circuit, and then we're going to work out the currents going through each resistor. So if I have two resistors here connected to a supply, that one's 8 ohms and that one's say 5 ohms. We know that 1 over RT, you can see that,